Alright, so let's now talk about the open-closed design principle. At the first glance, you might find the term contradictory because how can a particular components both be open and closed at the same time? It's actually not what it literally means. So let's go over the principle and I'll illustrate to you. Basically, whenever you say open-closed principle, you mean that in your system, you should really somehow have software entities like a classes or feature. They are actually open for extension and also closed for modification. But whatever that's open and whatever that's really closed, they don't overlap each other. So that's why there's no contradiction over there. Okay, so let's now, as we go over the definition, I would like to draw some visualization to show you for open-closed principle. Okay, so we talk about open-closed principle. Okay, so now simply imagine that if this is your system over here. Okay, so this is your system. And because of modularity, you might just divide your system into two parts according to open-closed principle. Okay, you're going to simply divide your system into two parts, maybe based on the classes or based on the features, but typically just by the modules, just classes. So one part is going to be open. So I'm going to use the green part, the green color, to say that part is actually open. So this will be the open part. So open part means whenever there is any extension that should really be implemented or introduced into your system, any new addition. When the extension are required to touch the open part, that would be considered as acceptable. All right. And then what about the other parts? So the other part of the system, once you decide, is going to be called a closed part. So that's why it's called the open-closed principle. So there should be such a decomposition of your system into two parts, open versus closed. So this part over here is a closed part. So closed part simply means if there is a particular extension that you actually want to introduce to your system, but very often such extension will simply just always touch the closed part. In that case, extension, let me just emphasize that. If extension to the closed part only happen rarely, that would be acceptable. Okay? Extensions will be okay if it rarely happens. But if it happens very often to the closed part for extension, so that means that part should have been declared as open in the first place, right? So once as a designer, you have to commit to how the composition should look like. Once you decide this part should be open, then most of the extensions should really go into this part only. Whereas there might be some rare part, very, very rare parts of the extension that might just go to the closed part. That'll be okay. Anything more than rare will be considered as unacceptable to the closed part. Okay, so let me, that's about a very verbal description. So let me write it down. So how can we judge if the open-closed principle is really satisfied, right? Let me just move this a little bit to the right over here. So now let's wonder about how can the open-closed principle be satisfied? Okay, so that's a question. So I would say there are several aspects you have to think about. Number one, there should be a clear separation or decomposition of the system into open versus closed parts. So that's the first criterion to judge whether your system really satisfies the open-closed principle. It's got to be documented down, the rationale. So it doesn't really matter which part is declared as open and which part is declared as closed. As long as once you declare them as open versus closed, you commit to it and don't change. Okay, so that's about the first criterion. All right, there should be a clear separation or decomposition. So that's the first criterion. So what about the second one? The second one is also necessary. The second one would be if there is a change. If there's a change. So now let's talk about the second and third criteria. So for the second criteria, mostly the change should touch the open part. All right, so that's why it's called open. So you can see mostly the changes should really touch the open part, which we talk about. All right, so what about the third one? So the third one is also very important. I would say rarely, if at all, a change may have to touch the closed part. All right, so this is very important to talk about rarely, and that a change may touch the closed part over here. If you have to touch the closed part very often, like more often than rarely, in that case, it's not a very good. You're not really satisfying the open-closed principle, because your distinction between the open and closed in the first place was simply not accurate about what's going to happen to your system over the time. Okay. All right, we're going to see example, but now for this slide here, for this page, I just want to draw to you the general definition for open-closed principle. It's going to be a distinction, and then for open part, most of the changes should really go touch this part only because it's open for extension. Very rarely, if at all, will a change actually be touching the part that's closed. Rarely is okay, but more than rarely, it's not okay. All right, so let's now go back to this definition here, right? So we talk about open and also closed, right? So you can think about the open part is somehow not very, it's kind of unstable, and the closed part is kind of stable, right? You can think that way. All right, so let's see one example over here. So since we are talking about the design problem for our expression language, so remember for the design language, let's look at the previous composite design over here. Remember for the previous composite design, let me show you this. We basically want to distinguish between structure, which is about the expression composite pattern, basically the structure, versus the operation. And the operation would be, for example, evaluate, print, and also type check, right? So we distinguish between structure and operation. So there are two parts of our system. So now, in order to satisfy open-closed principle, we have to make a decision. Should they both be open, or should they both be closed? Or should one of them be open and the other one be closed, right? So we have to make such distinction. We have to make such decision. Doesn't matter which one we make, as long as we can stick to it, and really it's going to only touch the open part mostly over time. As long as this is true, then we are satisfying the open-closed principle. So now let me talk about over here. Okay, let me just go over the slides and then I'll visualize for you. Okay, so now for our expression language, let's talk about only two alternatives. So let's not worry about when both are open and also when both are closed. So these are the two extreme cases. When your system is entirely closed, so that means you can never extend it. It's not realistic. And when your system is entirely open, so that means your system is too fragile to changes. So either way, it's not good. Let's not go for the extreme cases. So now let's talk about two alternatives over here. So now the first alternative is we talk about the structure being open and the operation being closed. And the second alternative would be the opposite. So the structure will be closed and also the operation will be open. So let's now visualize this. It's not really difficult. You just need some visualization to help you understand. Right? So now we talk about applying the open-closed principle to the language problem, okay, the expression language. Applying the open-closed principle to the expression language design. Expression language design problem, which is recursive, right? So now we talk about this, right? It's like an example of the open-closed principle we just spoke about. All right. So we talk about two alternatives over here. Alternative number one. Alternative number one over here, and also alternative number two. So both of them are basically talking about the same system. It's just that we are trying to make a different decomposition from one to another. Let's talk about the first one. The first one is saying that the structure is going to be open. All right. So now think about if this is your system over here. That's your small language system. And then we divide them into two parts over here. And one part is simply about the structure. And the structure includes, for example, you can see the constant, for example, 23, and also the addition, maybe 23 plus 46, and etc. That's about the structure. Okay. And there's another one called operations. And the operation will be, for example, evaluates and also type check. I'll just give you two examples over here. You know the rest. All right. So now let me just copy this one here because we are talking about the same system. Okay. So now we talk about these two. Okay. So now we talk about two alternative scenarios. Scenario number one, we want to make the structure over here open. Accordingly, the operation part will just be closed. We'll talk about the consequence for each one of them just in a moment. And alternative number two is the opposite. We want to say it should be quite rare there should be any changes to the structure part. And if there's any change, it should be more often that we'll simply do the change to operation. All right. So now let me just recap very quickly about these two alternatives. So these two alternatives, you have to commit to either this or this, but not both. As long as you can make a very clear distinction that we say either part is one part is open, the other part is closed, and one part is open, the other one is closed. As long as we can stick to it, and also any changes that's going to happen in the future really only touch the open part either here or touch the open part over here, then we are satisfying the open-closed principle. Okay, I'll do a little bit more further illustration to you in just a moment. All right, so now what we want to say is, in alternative number one, we want to say changes should happen here. Just to change the structure, I'll show you an example. And also for alternative number two, changes should really happen here. And let me tell you something first, and we'll actually elaborate that maybe later. So what about the visitor pattern that we're going to talk about for this lecture? That's the main learning outcome. If we want to really implement a visitor pattern for our particular development projects, in that case, in order to satisfy the open-closed principle, should we choose this alternative or should we choose this alternative? So that's a question, right? So let me tell you first. You can just make that as a note, but we'll explain why. So alternative number two is really the design scenario or design context or assumption. For the visitor pattern. So this means the following. If you want to judge to see whether you want to implement this visitor pattern or not, in that case, you have to think about if, number one, if I can somehow divide my system into structure part versus operation part. That's number one. Number two, if I can say that every time if I want to really make a change to my design in the future over time, it will be mostly the operation that I want to change. Whereas for the structure, I don't really have to change often. Okay, if that's the case, then visitor pattern will be the right design pattern to use. Right, we'll revisit this particular idea in many more details once we talk about the details for the visitor pattern. Okay, so now this page over here, the main thing is to show you the two different alternatives. Both of them actually satisfy the OpenClosed principle. Let me just emphasize this. Okay, otherwise you might be thinking that maybe only one of them satisfy the OpenClosed principle. So both alternative satisfy the OpenClosed principle. So which one should you choose? There's no right answer. You have to see how you vision the changes that are going to happen to your system over time. All right, let me now do just a little bit more illustration for you. So now we talk about the two alternatives, right? Let's talk about alternative number one. Alternative number one, the structure is actually open and the operation is actually closed, right? Let's say we try to commit to this particular alternative. So now, what do we expect to happen, right? We expect to happen that over the time, we really expect if there's any change that's going to happen, it should be happening to the open part, which will be about the structure, which means it would be okay if we simply introduce, for example, a new base case over here, for example, variable, right? We talked about this particular extension before. So this will be considered as acceptable because it's touching the open part, the structure. And also, we can also try to do extend the recursive part as another acceptable change. So maybe I will try to do maybe a multiplication, and that one there is going to extend here and here. Let's say I don't have the intermediate composite composite expression class, just for simplicity. So this will also be okay because I'm also touching the structure part. So now, what will be not considered as okay? For example, let's say now, if I want to introduce something to the closed part, meaning that I'm going to extend the list of operations over here. So now, in addition to evaluate, pretty print, and also type check, maybe I want to introduce another one called code generation. Maybe I want to generate maybe C code from Java code, or maybe I want to generate maybe MISP assembly code from the Java code, for example, right? So that's about extending it. However, we say that the closed part, if you very rarely update it, it will be considered as okay. So if code generation only happen once in a very long while, that might be considered as acceptable. But if you actually often have to make changes, for example, after you introduce code generation, and then you introduce maybe another one called optimize. Maybe you simply say, given a certain construct of your code, you simply want to optimize them by rewriting them in a way that's going to achieve better performance. So this is something to do with, for example, if you got SQL queries as your language, in that case, you can definitely optimize your queries so that it has better performance on the database, right? Just an aside. Okay, so now I would say if you have to do such changes often to the closed part, so these will be not considered as acceptable because you're updating the closed part. Okay, recap. If you chose to commit to alternative number one, in that case, updating structure will be considered as acceptable because you're updating the open part. However, adding things to the operations part, which was declared as closed, would not be acceptable. So that means this part either should have been declared as open part as well, or you're simply just doing the wrong thing to your system. All right, so that's about alternative number one. What about alternative number two? It will be the opposite scenario, but let me emphasize again, I'm not saying either alternative number one is correct or alternative number two is correct. They're both correct, as long as you can choose the alternative that works the best for your system. Then that means you're satisfying OpenClosed principle. Okay, let me just illustrate once more. So now, in this case, we are now choosing alternative number two. So that means any changes that's going to touch the open part will be okay, which will be for operation. So now, if I simply want to introduce, now I'm using a different color. So I'm going to use green for acceptable. So I can say code generation over here. I'm just extending with an extra operation. And then later on, maybe very often, I simply introduce another one called optimize. Even though I'm changing the operations often, that will be okay because I'm only touching the open part. So these both will be okay. On the other hand, what used to be acceptable by the alternative number one would not be acceptable anymore by alternative number two because now the closed part is about the structure. So now if I simply say, for example, over here variable, So now it's going to extend or inherits from expression. And then I also introduce another operation here, maybe division. In that case, it's also going to inherit from over here. So these would not be considered as acceptable because you're really touching the closed part. Touching that rarely might be okay, but we are really touching that way too often. In that case, it would not be acceptable. All right, so that's about OpenClosed design principle. Your fellow students normally find this principle confusing because they are not too sure which part should be open and which part should be closed. I would say go back to the definition of the principle over here, right? Given your system, you want to decompose it, you don't necessarily have to decompose the entire system into either open or closed. You can say you choose a subset of your system, and for that particular subset, divide that into open and also closed. For example, in the case of our language problem there, maybe your system contains many more components other than structure and operations, but you only choose these two components and then say one of them is actually open, for example, and the other one is closed. All right, so once you make that distinction there, you already satisfy criteria number 1 because you try to have a clear separation and commit to it. And for to satisfy number 2 and number 3, you have to monitor your system over time. So if over time, every time, very often, the changes are often touching the open part, but not the closed part, then that means you're satisfying the open-closed principle. If not, so that means you are touching the closed part way too often. So that means you may want to revisit number 1 over here to see how the separation should be elaborated or modified. All right. Finally, just keep in mind the alternative number 2 that we talk about, where the structure is actually closed, but the operation is actually open. So this will be the design assumption for visitor pattern. Okay, we'll talk about it later when we get to the detail. And let me just write it down for you. So this alternative number 2 over here is the design context or assumption of the visitor pattern. All right, so review the definition and then try to understand the two alternatives over here before you move on to the introduction to the visitor design pattern.